So, you're opening your purple thing to where it says overview and vocabulary, and we're on the top two. So the first thing we're going to learn today is dot plot. Hopefully it's not your learning. Hopefully you kind of remember this from middle school. But we use dot plots to display the frequency and distribution of the data.
First off, I'm gonna start by saying
You go to overview and vocabulary. Oh, so
you ain't give me one. You ain't give me one, Miss Kitty.
it's in your folder.
It's not.
Well, all right. So looking at this, what it is I put a dot on each thing there is. So we're going to do, first I'm going to have you fill in the notes. So not only are we doing dot plots, we're also doing histograms. So histograms are little bar graphs, but they're always connected because they're looking at intervals. So histograms are to show a set of data values that are closely grouped.
Shift to the left.
With no outliers.
Undisruptive.
Use the mean to show the center of the data and the standard deviation, which you don't need to really worry about. To show the spread. So you're just filling in these notes. And then I want you to flip the packet over so it's just that blank page. So it's like the back of the whole thing. This one closely grouped. Right here. Oh, for dot plots it says frequency and distribution. So the first thing we're going to look at one thing two different ways. So the first thing we're going to look at, so turn your packet over, is we're going to measure how many siblings you have. And that includes half, that includes step, how many siblings you have. So think about how many siblings you have. That means half, step, including everything. And then I want you to raise your hands when I call how many siblings you have. So let's start with 0. How many people have 0 siblings? They're an only child. Raise your hand.
Wait, including us or no?
Not including, no. You have no siblings. These are just siblings. So you have 0 brother and sister.
Okay. I was fine.
Don't play. This is going to be really hard. How many have just one sibling? Like one brother, one sister?
25.
Only Amari. Cool. How many have 2 siblings?
Me?
1, 2.
Oh, I got
just 2. 2 is the max you have. 1, 2, 3, 4.
I got 3 siblings.
No, not including yourself. Keep them up.
Well, I got 3.
2 siblings, a brother and a sister. 2 brothers. 4, 5. 5. How many have 3? I have 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10. How many have 4? 1, 2, 3.
No.
3.
Wait, so we don't include ourselves, right?
No. How many have 5?
That's
1. Who has more than 5? Nobody? Cool.
That's
Wait,
good.
who said they got 4?
I got 3. Oh,
So,
yeah, you
how we make the box plot or dot plot?
to kill.
I'm gonna put 5 down.
To kill.
You like everybody's sister. Stop. This is recording.
You like everyone.
So, what you're doing is you're putting the numbers of siblings. So I start with the smallest. I'm just starting with C. Actually, no. I'm starting with the smallest of my numbers. What's the smallest of my numbers?
1.
1. So 1, 2, 3, 4, 5, 6. Now, I'm just putting a dot for each person. So how many people have one sibling?
One.
How many people have two siblings?
Five.
So I go 1, 2, 3, 4, 5.
I like that.
How many people have 3
10.
siblings?
We did this at elementary school.
Great. I did not go to math last night.
Great. Oh, we had that on Delta today. We got that on Delta.
How many people have 4 siblings?
Three.
3.
Is that thing that you saw?
One.
And then
So
1.
much.
So
Oh
last class
my.
did not look like this. Do you see how it's perfectly, and I didn't do this on purpose, see how it's almost perfectly in a curve like this?
Yeah.
Right in the middle? It looks kind of like a
Parabola.
parabola. But we call that a normal distribution.
Y equals mx plus
So-
c.
Do this graph on the back?
No,
Yeah.
this is ax plus bx plus c.
So normal distribution is when it's symmetrical. So almost like a parabola, right, where it's symmetrical. A normal distribution means it's symmetrical. That means it almost looks like a wave. Like it's not one way or the other. It's pretty symmetrical right here. Does that make sense? Yes, no, maybe? It doesn't need to be perfect. You don't need to write exactly this down if you've been already. We're going to go to another one. Next one we're going to do is the number of pets you have.
Wait, what was it called?
Normal distribution.
My pet died. His name is Louie. Yeah, it was a fish. And it was a
So
pet.
this includes all pets. So think about how many pets you have.
Now we're gonna take that with.
Now. No, now. What you have in your house right now.
Wait, can it be like?
Look, I put food in this bowl and I left for a week.
Every time we take it out?
Hey,
Yeah.
I
he was
got
just sitting at the bottom of the bowl.
Like
And then
an
I took the
actual
bowl and like
pet.
his body.
All right. How many people have 0 pets?
Wait, do they have to live with us?
Duh.
Yeah.
No,
live with you.
okay, I have.
How many people have 0 pets? Raise your hand. 1,
I got
2, 3,
0.
4, 5, 6.
All these people that.
6 people. How many people have 1 pet? Isabel, Brian, Fernando. 4. 4. And Daniel, I think it's Daniel. How many people have 2 pets? I have 2 pets.
1, 2, 3.
How many people have 3 pets? 1, 2, 3, 4. How many people have 4 or more pets? How many do you have, Pablo?
Whoa. It's like 12 birds, right?
I got 2.
I'm broke.
You have 4 birds flying around your house.
No, they're a cage. Like a big cage.
12 birds.
In your house?
12 birds.
So there's 2 turtles, 1 fish, and a dog.
Wow.
So 12 birds.
Yeah.
12 birds.
Yeah. No, it's 2 turtles.
No, hold on. 12 birds.
I love learning
12?
stuff, Pablo.
Oh my God.
What do you have in 12 birds for?
I used to have 3 pet birds. I also had 2 pet iguanas.
You have 12 pets?
I would have
Is that what
said
you said?
He had 12 birds and then more pets, so it's 15 pets.
Yeah. Okay.
So you heard it, yeah.
How many do you have to have? 5.
5.
I got 3 English mastiffs and 2 rabbits.
Whoa. I think 2 dogs is way more than that.
Yeah, me too. I'm
No, we
gonna
only kept 1 because my dog had puppies. We just kept 1 puppy.
Well, there you go.
what did you do with the
Anybody
other
else?
three?
Not on here.
That's messed up.
Okay. So now, let's do our dot plot.
That's a lot.
Yeah.
English mastiffs.
So I'm gonna start with 0, 1, 2, 3, and draw this on the back too. 6, 7, 8, 9, 10, 11, 12. Cool. So how many people have 0 pets?
You didn't do
that. Oh, there's
I don't even want to do this.
4, 5, 6. How many people have 1 pet?
5.
5. 1, 2, 3, 4, 5. How
It's gonna
many
be
people
shit
have
to the left.
2 sits? 2 sits. 2 pets.
3 is
3. Whoa. How many people have 3 pets?
4.
You forgot another dot. 1, 2.
Shut up.
I did. Shut up.
There you go. How many people have 4 pets? 0. I don't put anything. 5 pets?
What?
And then here is Pablo. What would Pablo be considered in the data?
Outlier.
Does that make sense why we do
What do
outliers?
you need 12 birds for?
Birds are amazing.
You seem like
Okay, they're not even that hard. So now when I draw this, right, let's draw the curve. Let's draw the curve.
How big is that lady?
Does that look like a normal distribution?
No, that looks like shit to the left.
Do you guys see how the tail is at the right?
Yeah.
Wherever the tail is, we call it skewed.
Exponential.
Oh, I remember this cute.
It is. She's thinking of the graph. It is like a curve like that, but this is called skewed. So instead of normal distribution,
Good job, Kamari.
it's called skewed. And you look at where the tail is at.
Skewed exponential.
So where is the tail at? The right or the left?
Right. Skewed right.
So this is skewed right.
Skewed right exponential.
Does that make sense? This is skewed to the right because the tail is at the right. If the tail was at the left, it would be skewed to the left. All right, so we're gonna get back to doing it as a class, but right now I just want you guys to practice. So on your purple packet thing, see where it says dot plots? Open it up to the dot plot section, and we're gonna be doing those two. So they look like this. So you're doing the same thing. They're giving you, this is how many, 20 students, how much they slept. And so some of your guys, I stapled a little bit too close. So you can't see that line. Draw that line if you can't see it. Now, what's the smallest amount of hours here? 4. 4 in this one, it would be 4. Yeah, it's 0's in the next one. What's the largest amount?
9.
And then I just fill it in. 5, 6, 7, 8. We're on the first one. It says dot plots right there. So if you don't want a line, just draw it. Or where it says dot plots. Dot plots.
Yeah, it's like.
Okay, so
You can't see the line.
I know, just draw it though. So now you're just saying how frequently you see that number. So how many times do you see 4?
A lot.
Count.
2.
2, right? And cross it out when you're done. 1, 2. So I go 1, 2. How many times do you see 5?
Sorry.
Let's see, 1, 2, 3, 4, 5. Good. So I do 1, 2, 3, 4, 5. How many 6s?
7.
1, 2, 3, 4, 5, 6, 7. Beautiful. 1, 2, 3, 4, 5, 6, 7. What about 7?
3. This could be an ASMR with all your notes. You need ASMR.
How many 8s?
2.
How many 9s?
Parabola.
And so if it looks like a parabola, what type of distribution is it?
Quadratic.
Normal distribution.
AX plus BX equals C.
It looks like a shape of parabola, but it's not. We're talking about statistics.
I like parabolas.
Normal
Me
distribution.
too, they look like imagination.
Imagination.
How weird. I thought that's the one. That makes sense. Okay, try the next one on your own. It's the one at the bottom. So this one's saying how many people that miles they did during the month challenge. So you're just doing the exact same thing.
Let's do the pulse count.
Good. Fernando, how many on 4? Ryan, how many on 5? It is 5. Pablo, how many are on 6?
3.
Zaylen, how many are on 7?
Zero.
There's no 6 7s in that list.
Oh,
Three.
3. Come on, how many on 8? 2. Beautiful. Nathan, how many on 9? 3. Charmaine, how many on 10? 1. Tremonti, how many on 11? 0. And how many on 12? Yep, so it's not perfect, but if it looks like a wave, we know what type of distribution is it. Remember, normal. Normal distribution. If I can write it. All right, turn your paper back over. We're going to do histograms now. So what I want you to do is I want you to think about how many letters are in your whole name. That means first, middle, and last.
Oh.
Yes, all your names.
Wait, put it on where?
Count how many letters are in your name, including your middle name. Yeah.
There. Oh, right.
Just write the number down on your purple pen. Like this, write that. Count how many names letters are in your name. How many letters in your first, middle, last name. Just write it at the top of the paper. We're gonna do like a class. All of it. No dashes. Dashes and stuff don't count.
Yeah.
Like the
Wait,
dash
all
doesn't count as a
together?
letter.
First name, last name? Or first name, middle name, last
First name, middle name, last name, all of them. So if you have 2 last names, then you're counting both of them. I can count mine.
I forgot.
Mine's 21, so I'm putting 21 right there.
I got 20.
Who thinks they have the smallest amount?
Me.
How many do you have,
I got 12.
including your middle name?
I got a middle name.
Okay, cool. So 12. So I'm going to do intervals. So if you have between 12, actually, no, we're just twins. So 12 is Pablo. Anyone have 13? 14. I'm going to do intervals, right? Yeah. Okay. So we'll do 12 to 14 is 1. How about 15 through 17? Does anyone have 15 to 17 in their name? Ms. Thompson? Anyone else? Andrea? Anybody else? What about 19 through 20? This is not even. Yeah, this isn't even. Wait, 12 to 14.
2.
Oh, it is even. Okay. 18 through 20. How about 18 through 20? 1, 2, 3, 4, 5, 6. Anyone I missed? 21 through 23. I have 21. Traumazed. Anyone else? You're at 20? But you're 31? So you didn't come yet.
Wait,
All right.
what are we lower than 12?
What are you?
10.
Okay.
She called me Dayona.
9, 2. All right, 24 to 26. Who has 24 to 26? 1, 2, 3, 4, 5. 27 through 29. 27 to 29. No one? Anyone have more than 29? How many do you have? 31. How many do you have? 31. Anyone else? Higher than 29. So 30 to 32. Cool. Did I miss anybody? So now what we're doing, do this on the your purple paper. We're making a histogram. So now we're doing histograms. So what histograms are, you're dividing it into intervals, just like we just did. So here's 9 to 11, 12 to 14, 15 to 17, 18 to 20, 21 to 23, 24 to 26. I have to squeeze them in, and then I'll put 30 to 32 here. 27 to 29. Okay, how many people had 9 to 11? One, right? So I'm gonna go like this and go to 1, and it's gonna look like that. One person. Here's Daniel. How many people had 12 to 14?
One.
1. Here's Pablo. How many people had 15 to 17? 2. See how they're all connected too?
Yeah.
If your bar graphs are not connected, histograms are. How many people have 18 to 20? 6. Somehow have to go all the way up there, so it's going to look like this. What's the term that I have if this is the most? What term do I use if the number shows up the most? Mode, right? What about 21 to 23? 2. 24 to 26? 5. And then we skip 1, and then the last one was 2. Cool. And so that's just how we make a histogram. Now notice this shape looks like this. It's a curve, and then it goes down, and then it's another curve, right? See that? How it goes up and down twice? What word for a brain bug means 2 in math? Raise your hand. What?
Double.
Another word.
Not double.
Yeah, bi. Yes. So bimodal is what this is. It just means it has like 2 bumps. So bimodal means it has like 2 bumps in it. So there's bimodal and then the skewed and normal distribution. So that would be a bimodal. Cool. Does that make sense?
Yeah.
All right. Let's go to your, now you're opening your purple packet to where it says histogram. So now you're opening up your packet where it says histogram. And I'm going to give you the intervals right here, so copy these down. So copy these down. This should be 18, 20, 22, 24. It's the next part of that purple packet. Yeah, we're still in the purple thing. Like, yeah, example 3. It's in the top. And then right here is 1, 2, 3, 4, 5, 6, 7, 8, 9. See how this is your folder. So once again, we're looking at intervals here. So I can see the first interval is between 18 and 20 minutes. That means they're faster. It took more time for them to run than 18, but less than 20. In the first column, is anyone 18 through 20? No. Nope, because 2040 is after 20. What about the second column? Nope. Third? Anything below 20? Wait, yeah, there is. Third one? Who's below 20? 18 and 18, so that's 2. Then this 19, 3. This one. Beautiful. I think that's it, right? Cool. So how many people are from 18 to 20? 5. So I just go right here and I bring it up to 5. This is what the delta math looks like too. Now let's do the next one. Next one's 20 to 22. 20 to 22. So from here, how many are 20 to 22? How many right here? Like the time between 20 and 22 minutes. Yep, this one. 1. How many in the second column?
1.
Here's 1. Here's 1. Here's 1. 3. It's just between 20 and 22. So I would make sure you're writing these numbers down.
There's 4 on the 3 on the 3 on the 4.
Yep, 1, 2, 3, 4. Beautiful. 1, 2, 3, 4. What about the last one? 1, 2.
3.
So that means how many people had times between 20 and 22? 10. So I'm going to drag this up to 10. It looks like that. Cool. Next one is 22 to 24.
Mark.
So from 22 to 24, how many?
Ooh.
22 to 24, how many in the first one?
2.
1. Yes, 2.
Oh.
This is the last one that I'm going over to. So 1, 2. How many in this column are between 20 and 24? Sorry, 22 and 24.
1, 2.
2. There you go. This column.
What?
How many?
1.
1. This column.
0.
This column.
What'd you say?
1. How many is that total? 6.
I have to give her the joiner.
All right, now we're in the
Nah, you
middle.
go like this.
All right, next one. 24 to 26. Anyone in this one? Yep. 1, 2. What about this one? Nope. Next one.
Wait.
Third one.
Oh, 1.
Yep.
Where's that in that?
Next one.
Really, no.
How many total? 5. Leslie, you should still be writing this down. 26 to 28.
Your controller is broken.
How many in the first one? 1. How many in the second one?
Battery.
We're still writing.
Oh, you are?
1, 2. How many in this one?
I did not know you were.
1. And that's it. So 3.
I got a question. I didn't go over
Wouldn't that be 25 to 26? Yeah.
there.
Well, it's 24 up to 26, so technically like 2601. You know what I'm saying? So like 26, like if you run, Dante. If you run, right? Like if you run a perfect 26 minutes flat, that would be up to you. This would be like 1 second after 26. And then how many are at 29 or 30? 1. So it looks something like that. When I draw this, is the data skewed or normal? Skewed to the what?
Right.
You to the right.
Yes, sir, boy.
Because the tail is at the right.
Yes, sir, boy.
Beautiful.
Yes, sir, boy.